In this second video on multiplying monomials, we are going to cover slightly more difficult problems involving the multiplication of monomials. So here's an example in the upper right-hand corner here. These are obviously more complicated than we dealt with in the first video. We have one monomial multiplied by another monomial. And what makes these more difficult primarily is that we have more variables. You can see that we have in this example an A, a B, and a C variable, three different variables. And the exponents tend to be larger as well. You can see that A here has an exponent of 4, B has an exponent of 2, B has an exponent of 4, C has an exponent of 3. And just a reminder that when you don't see an exponent, we need to think of that as an exponent of 1. All right, but the procedure is going to be the same. Let's review those steps. We multiply the coefficients in front of the variables. Now remember, another thing that makes these more difficult is when there's a negative involved. When one of the coefficients is negative, when there's one negative coefficient, it will make the final coefficient negative. So it will look like a negative answer. When there's two negatives, when both coefficients are negative, it will make it positive. And we'll go through examples of both of those in a moment. Number 2, add the exponents for each variable to get the new exponent for that variable. Another way to think of this, for the example above, where we have A, B, and C, how many A's? So we look at the exponent to tell us how many A's. There's 4 A's here. There's one more A here. So we have a total of 5 A's. So that will turn out to be A to the 5th. How many B's? There's 2 B's here. There are 4 B's here. We add those together. We get B to the 6th. And how many C's? 1 C here, 3 C's there. We add those up, we get C to the 4th. So as long as I've done that part of this problem, I might as well multiply the coefficients. -6 times +5. There's one negative, so that will give us a -30 as our coefficient. All right, let's go look at 4 example problems. Number 1, we're going to make these more complicated as we go along. I want to talk about 2 different ways of thinking about solving these problems. In this first one, I want to talk about the fact that for a problem like this, we're always going to end up with a coefficient. That box represents where the coefficient is going to go. And we're going to have one spot for each of the different variables. So let's look at what we have here. We have an X and a Y, and we have a Z in the second monomial. So our answer is going to have an X and a Y and a Z. Every variable that is in this multiplication process is going to show up in our examples. Now, each one of those variables is also going to have an exponent. I didn't make those boxes very big, but let me now write my answers in a different color. Our coefficient is going to be 2 times 5. That's 10. Our coefficient for this product will be 10. How many x's do I have? One x here and another x here. That gives me 2 x's. Sorry, that 2 is very small. Y and another y, that gives me, let me write that up here. That's going to be 2. Write that first one up here as well. And how many z's do I have? Well, I just have one z. So our exponent for z is going to be 1. Let me rewrite that in a different color down here. So our final answer would be 10x to the 2nd power, y to the 2nd power, C. So that's one method to think about solving these, counting up the number of each variable. Sometimes it might help to rearrange, and I demonstrated this in the first video on this subject. And what I mean by that is let's get the product of the coefficients together. 2 times 2. And then let me get the x's together. We have x here, and that's going to be times x to the third power. Let me get my y's together. I have y in this first monomial. I have y to the second in the second monomial. So we've just rearranged the terms, and this might make it a little bit easier for you to do that multiplication and counting. 2 times 2 is 4. How many x's do we have here? Remembering that this is 1, that's x to the fourth. How many y's do we have here? Y and 2 more y's, remembering that that is y to the first. That leaves us with y to the third. And that would be our answer to that question. Remember, we looked at this and we only see variables of x and y. So we're going to have an x and y variable in our answer. All right, let's take a look at number 3. And I'm going to use the rearranging approach for this one. The more complicated the problem, the more variables, the more negatives involved, the more the rearranging approach might make sense for you. So we have -4 times -3. Those are our coefficients. Then we have an x variable, and here we have x to the 6th. So let's put those together. X times x to the 6th. We have a y variable times y to the 3rd. And we have our z variable, but there's only one z variable. So that will just be z. And now we can multiply our coefficients. 2 negatives make a positive. So we know that the product of these two will be positive. 4 times 3 is 12. X to the first times x to the 6th. 1 plus 6 is 7. Y, we have 1 y here. We have 3 y's here. That gives us a total of 4 y's. And z just carries through to our answer. We don't need to do anything with the z. So our answer becomes 12, x to the 7th, y to the 4th, z. One more. Let me do this one the other way using this approach. We know that when we're multiplying 2 monomials, we're always going to have a coefficient. And let's take note of our variables. We have an a and a b and a c, an a and a b and a c. So we know that we are going to have an a and a b and a c. Let me make larger boxes for my exponents this time so that I have room to write. Each one of those variables will have an exponent. Let me change my color. -5 times +3. Because one of those numbers is negative, we know that the product will be negative. 5 times 3 is 15, so -15 is our coefficient. How many a's do we have? 1 a plus 2 more a's. We have 3 a's. 1 b plus 2 b's. We have 3 b's. And 1 c plus another 1 c, that leaves us with 2 c's. Now let's just rewrite this so that this is clear what our answer is. -15, a to the 3rd, b to the 3rd, c to the 2nd. So I think you've seen that these problems don't have to be more difficult than the ones we went over in the first video. You just need to be more careful and make sure that you are taking your time and looking carefully at each variable and each exponent and adding them up carefully. If you do that, you should be able to handle these kind of problems just fine. So go ahead and tackle the 10 problems that follow this. If you have difficulty with that, as usual, come back and watch this video again, and then try those problems a second time until you can feel really comfortable with solving these kind of slightly more complicated monomials. Good luck.